Hey everyone, today we're going to kind of continue. This is kind of like a part two to the area model with division. Okay, so I really do think it takes a couple days to look at this. I know one video isn't enough, especially in the beginning when it feels really confusing. So today I'm going to try to buzz through a few more problems to give you the examples of what they look like to get you thinking about this process. And then hopefully it will feel a little more comfortable with you trying to solve that out. So today we're going to take the number 147 and we're going to divide it by 7. Okay. Now I'm going to use an area model to do this because again, I could make 7 circles and then start to put 1 in each until I get to 147, but I will be here way too long. The video wouldn't even allow that. It wouldn't even let me record that long, I swear. So what we're going to do is we're going to use this area model process. So again, area model is something that we've done when we multiply. And so we're just going to use that same idea, but we're going to turn it into a division problem or model, if you will. So remember, area, array, rows and columns make a rectangle. So just kind of put those words together all the time and now, okay, yeah, cool. Step 1, I'm going to build this rectangle. Okay. Now this rectangle is going to be divided by 7. So that's my number on the side because I'm going to take 7. I'm making like 7 groups. Now, instead of trying to worry about 7 broken into 147, what I'm going to do first is I'm going to make compatible groups of my 147, meaning I'm really going to section off my whole rectangle into parts that make sense. For example, I'm going to cut right here, and this is going to be a 7, right? So, and again, I keep trying to capture this on the side. You can see in my head what I'm thinking is I have 147 total, but I made a little section of 7, which means I have 140 left. And then the tricky part is I do have to think about 7, like how 7 will fit into things. Because like, for example, if I put a 10 here, well, 7 does not go into 10. It like doesn't work, right? I mean, it does, but it doesn't work as a whole number. So those numbers aren't really compatible. So again, I'm not going to chunk off a section of 10. So let me see here. Maybe I'll do, oh, actually here, this is cool. I'm going to do 70 because I know 7 times 10, right? Like those are compatible numbers. So I'm going to, oops, probably make sure my pen's working. I'm going to chunk off a section of 70, which leaves me with 70 more, which means I could just make this last part 70. Okay. And again, what I'm doing there, just to clarify what this is I took my rectangle, which I know is 147 big. That's how big that rectangle is. But instead of worrying about 147, I cut it into sections that I could work with. 70 plus 70 plus 7, that's 147. Those are compatible numbers. Okay. So now I'm going to use this area model to help me. And what I mean by that is I just have to start thinking, oh yeah, well, when it was an area model, we had a number up here and we multiplied it by this number and it equaled the number in the middle. Right? So I have to think to myself, 7 times what gets me 7? And then I have to think 7 times what gets me 70? And then I have to think again, 7 times what gets me the other 70. So that's the math I have to do to help me do it. So let's do that math. Let's think about that. So, oh boy, that got big. Okay, so 7 times 1 equals 7. I know that. So up top here, I have a 7. And then I already said this because, again, I'm always thinking about numbers I know. I said, oh, yeah, well, 7 times 10, that equals 70. So this number up here is a 10. And then since I already know 7 times 10 is 70, then that's just another group of 10 So in order for me to find my answer of 147 divided by 7, I'm going to look at these numbers up here. And if I add those together, oh boy, I see I erased my problem itself. I have 10, 21. So what this means is 147 divided by 7 equals 21. Okay, we're going to get there. Don't worry. Let's keep trying it. So let's come up with another problem and put this to practice. So I'm going to go big. I'm going to go 285. Yeah, I said it. And we're going to divide that by 5. Let's do that. All right, so again, area model, how I can do this. I'm going to start and I'm going to draw a rectangle. Now this rectangle represents, as a whole, it represents 285. Right? This side represents 5. Okay, so yeah, sorry, I was just trying to think of another way. Here, let's look at it this way. This might make a little sense. If it's not yet, again, why I'm doing this rectangle, that's probably a pretty good question. So if we had 285 divided by 5 equals something, remember the inverse in math states that then that same something times 5 equals 285, right? So why I'm building this rectangle, I don't know why I didn't think of this earlier. I'm glad I thought of it now, though. This should, hopefully you're stoked you're watching this video. What that means then is that if I drew that as an array, like when we were doing multiplication, well, one side is 5. The other side, I don't know, but when I multiply it together, I get 285 in the middle, right? And again, we did that in various ways, but technically that's kind of the breakdown. Well, what I'm saying now is we still don't know what, I was supposed to erase. We still don't know what this is up here. Like, my goodness. We still don't know what this is. And although we know this is 285, why I keep writing it down here is that I don't know 5 times something is 285. Like, I don't know that answer. So to help me answer that, I'm going to break my whole rectangle into sections. So for example, I'm going to make a section of 5, right? So I have 285, and right now I just took 5 out of it. So that leaves me with 280. And then I'm going to think, okay, let's see, what else could I do that's a large chunk? Oh, you know what? I'm going to do a chunk of 100 because 5 times 20 is 100. That's, again, compatible numbers I know. So that leaves me with 180. And then, you know what? Let's take another chunk of 100. And that leaves me with 80. Let's see here. Oh, let's do a 50. All right, this is a chunk of 50. So I had 80. Oh, wait, I can just scroll. Sorry. I had 80. I just took 50 away. That leaves me with 30. Oh, and then I'll just make this last section 30. Now, what I did here, down to 0, what I did here is, again, instead of thinking about 285, I broke 285 into all these different sections. I did a section of 5, a section of 100, a section of 100, a section of 50, and a section of 30. Again, if I added all those up, it would be 285. So I'm just going to think about it by part by part. And now I can use my multiplication facts to help me, because what I get up here, those are the answers I want to help me find the division, because it's an inverse. So 5 times what equals 5, right? So to me, oh man, come on. To me, I know that 5 times 1 is 5. And then again, 5 times 20 equals 100, which is the same thing for here. 5 times 10 equals 50. And then 5 times 6 equals 30. Now that I've done that, to find my final answer of what's 285 divided by 5, again, because it's the inverse, I'm going to add these numbers. Sorry, I keep clicking buttons and for some reason it's not working. I'm going to add these numbers together and that's going to be my answer. That's going to be my quotient, the answer to a division problem. That's going to be my answer. 285 divided into 5 groups is going to get me, let's see, 20, 40, 50, 56, 57. So 285 divided by 5 equals 57. And again, I did this using an area model. Okay. All right, let's do one more. I hesitated, but let's do one more. Let's do one more. I'm going to try to like talk about it the way that we did before. So I'm going to take, let's do 184. We're actually going, let's just divide this one by 2. Okay, I'm going to try to speed walk this one a little bit. Now remember, we're going to think about the inverse. The inverse means opposite. If 184 divided by 2 equals a number, then that same number times 2 is going to equal 184. So when I think about my model, I'm going to take it, and I know that this side is 2, right? There's my 2 that I know. And I actually don't know what's up here, but I know that the inside is 184. But I don't know 2 times something is 184. So again, instead of worrying about 184, I'm going to take this rectangle of 184 and cut it into parts that are compatible. For example, I'm going to take and I'm going to make a part of 4. Again, here's my brain over here. So I had 184. I just took a part of 4 away. I have 180 left. Let's take away 100. Why not? Because I can think about how, so it's a chunk of 100. That leaves me with 80. Gotta think about 2's, what I know about 2's. Oh, I can do 80. I actually can do 80. So I'm gonna put this and make this a section of 80. So again, I'm done because what I did is I took 184, but I put it into a 4, 100, and an 80. I just added those up to make 184. Now, to get my final answer, right, we have to think about what these numbers are at the top. 2 times what equals my numbers in the middle. So again, we're thinking 2 times 2 equals 4. That's true. 2 times 2 is 4. If I think about 2 times what is 100, that's actually 50. And the reason why I know that is because 2 times 5 is 10, and then there's a 0. So I need a 0 in my answer. So that's 50. And then same thing with 80. This is why I was like, oh, I know 80, because I know that 2 times 4 is 8, but there's a 0. So I actually need a 0 here. So it's 40. So there I have it. I actually just solved this by cutting it into parts. And what I'm going to do again is I'm going to add these top numbers to get my final answer. So 50 plus 40, we'll put it over here. That equals 90 plus 2 more equals 92. Sweet. So 184, or yeah, 184 divided by 2. I swear that's a 2. I just looked at it. I was like, that looks like a Z, equals 92. There's our work. And again, this is how we can do this using this area model, okay? Try it. I know it can feel frustrating and weird and crazy, or maybe it feels great, right? Like I said, the more you practice it, the more it's going to make sense. The more it makes sense, the easier it is to go through it. Don't feel discouraged if it's still confusing. Just keep practicing it. And if this technique doesn't stick or make sense, trust me, the next one will. So keep practicing, and then eventually you're going to use the strategy that works best for you. Okay, so thanks as always, and we'll see you next time.